All right, so the last thing that we did, we added and subtracted rational expressions, but we had what kind of denominators before this? Common denominators. So now we have uncommon denominators. So let me start with one that's kind of like a bridge between what we did before and what we're going to do today. So let's take a look at this. This is example 5 in the book. So if you look in the book, you'll see this example. So it's 2x over x minus 3 plus 5 over 3 minus x. So are the denominators the same? No, they're not. They're almost the same, though, aren't they? Okay, they're just kind of flipped, right? So it would be really nice if I could just have a common denominator and make it x minus 3, right? If they were both x minus 3, that would work out pretty nice, wouldn't it? Because I just add the top, keep the bottom, x minus 3. But this one is not x minus 3. It's close to it, but it's not quite. So what would I need to do to this in order to make it look like this? Well, I'd have to change the 3 to a what? A negative, and this negative x to a positive. So how could I do that? What could I do to this thing? I put it in parentheses, gave you a big hint. Very good. Multiply by negative 1. Now how can I just randomly multiply the bottom by negative 1? Well, I can do that as long as I do something else. Multiply the top. Because really, what did I just do? I just multiplied the top by negative 1, the bottom by negative 1. What's negative 1 divided by negative 1? It's just a positive 1. So really what I did is I just multiplied that second fraction by a positive 1. Do I change it by multiplying by a positive 1? No, it doesn't change it at all, does it? But by making this negative, it changes the order and it makes it look like this. All right, so let's rewrite this. We'll keep the first one the same. We didn't do anything in that first one. Nope, because we already changed it. See, the negative 1 divided by negative 1 is a positive 1. And so I didn't change the value of it, but I did change kind of what this bottom one looks like. And that's what we wanted to do. So what did I get here? It's a negative 3. Move my pen around. It's a negative 3 what? Plus x. But instead of writing negative 3 plus x, isn't that the same thing as this? Let's just make it look the same now. Instead of negative 3 plus x, how could I write that? Yeah, you could put plus negative 3 or just x minus 3. Now they're the same, aren't they? But what's my top going to have to be now? It was a 5, but now it's a negative 5. You see that? So I multiplied the bottom by a negative, and it turned into what I wanted it to be in the first place. But you also had to make sure that you multiply the top by a negative as well, so that the value of this thing is going to be exactly the same. So now it's pretty easy. Just keep the denominator the same, since now we have a common denominator, because it says uncommon denominators, but we're always going to change the uncommon denominator to a common denominator, and that's what we're trying to do here. So we change this to x minus 3. Now we have a common denominator. Now what can we do at the top? Just go 2x. You could put plus negative 5, but what's a nice, cleaner way of writing it? Just minus 5. Does anything cancel out here? Does this x cancel with this x? No, we had a whole thing the other day about that. Nothing cancels out here, so that is your answer. So that's your first one. Okay? The rest of them are a little bit different, though. All right? That's definitely the easier one. But it's one that kids get mixed up on, but hopefully you understood what I just went through. All right? I'll just put it right there. All right, let's go back in time, back to when you learned fractions for the first time. I keep planning on talking to an elementary teacher to find out when they introduce fractions, or at least adding or subtracting fractions with the kids, but I keep forgetting. And so it is different for everybody. But I'm just talking about Red Lion, okay? So I just want to find out when in Red Lion's math career, in a Redline student's math career, do they learn how to do fractions? I don't know. So let's do this. I'm just going to make this up. I didn't put this in the notes. Actually, yeah, I did. So let's do this. I do have it in my notes.
Is this like an example? Or?
This is not an official example. This is just kind of leading us up to what we're going to do next. I think we might have done this the other day. I don't know. If not, we're going to do it again. Let's take a look at this. Remember back in the day, you had to add fractions?
Yeah.
Let's do this without using a calculator. How would I add these fractions together?
3 times 5. Find a common denominator.
It's that. Exactly right. Find a common denominator. Okay? And I can't make that plus. Let's try this again. There we go. All right, that's better. So I need to find a common denominator. So I got a 3 and a 5. So I need to find a number that 3 divides into and 5 divides into evenly. The smallest number that 3 and 5 both divide into evenly. What would that be? It'd be 15. Okay? What's one easy way to get 15? Just multiply those together, right? You're not always going to just multiply them together. There's another way to find the least common multiple. We'll talk about that in a minute. But in this particular case, yeah, just multiply 3 and 5 together and you get 15. That means 3 divides into 5 and 3 divides into 15 and 5 divides into 15. Now, here's the key to this. What did you do to this 3 in order to get that 15? Okay, so you multiply the bottom by 5, and very similar to what we did earlier, you're going to have to do what? Multiply the top by 5. Now, why can you do that? We just talked about it. What's 5 over 5?
1.
It's a 1. So really, we just multiply that by a 1. Did that change the value of it? No, it didn't, okay? But it changed what the numbers were, right? But it didn't change the value of it. Because what's this going to be? This is going to be 10 over 15. Well, 10 over 15 reduces to what? 2/3, 2 over 3. Everybody see that? So it's the same value. We just made it look different because I want to have a common denominator so I can add them together. So what's the top going to be? 10. Let's do the same thing to this. What did we do to the 5 in order to get 15? Multiplied by 3. So what do you do to the top? Multiply it by 3. It's supposed to be a dot. And then what do you get? 12. Now, we're ready to add them together. So our common denominator is 15, so I just write one denominator, write it 15. And then what do I do to the top? 10 plus 12 is 22. And I just leave it like that. As long as it's reduced. Is it reduced? Yeah. Only 3 and 5 go into 15. 3 or 5 doesn't go into 22. So nothing reduces. You don't need to change it to a mixed number. Okay? You don't have to in a math class. All right? Now, if you're doing real work, remember, I think we mentioned this Friday, if you're a carpenter or something like that, you know, you're not looking at something as 22/15. You're looking at it as what? 1 and what would that be? 7/15. Okay? But we're not carpenters. We're not engineers just yet. Maybe some of you will be eventually, but we're just going to keep it improper fraction. As long as it's reduced. As long as it's reduced. Everybody good? All right, let's do another one. And I didn't write this down, and I should have been better prepared. Let me see if I can make one up. Let's say 3 over 8 plus 5 over, let's say 15. No, let's not. Let's say 14. Okay? This one's not quite as nice. But I got to find a common denominator. By the way, the common denominator, remember I said you want to find the smallest number that 3 and 5 divide into evenly? So what about 30? Would 30 work? Does 3 divide into 30? Yeah. Does 5 divide into 30? Yeah. But is that the smallest thing that 3 and 5 go into? No. So it's not the least, what is it? The least common multiple. Least common multiple, LCM, right. So I want to find the least common multiple. Now, we're going to leave this, and we're going to go to the algebra stuff, the expressions, right, with x's in there and all that kind of stuff. And eventually, yeah, we'll have squareds in there and all kinds of stuff. But right now, let's just deal with these little numbers right here. So here's how I'd find the common denominator. Because 8 and 14, it doesn't really just register. 3 and 5, that was easy, right? I knew 3 went into 15 and 5 went into 15. Well, what does 8 divide into, and what does 14 divide into? To tell you the truth, I'm not just saying this either. I really don't know. All right? I really don't know. So what I'm going to do is I'm going to figure it out. I can figure it out, though. So watch what I'm going to do. I alluded to this the other day, but I kind of brushed by it super quick. So we're going to get into it right now. All right? So what I'm going to do is this. I'm going to take the 8 and the 14, all right, and I am going to break them down into their prime numbers. Okay? So what times what is 8?
2 and 4.
2 and 4. But are both of these prime? Not yet. So what's 8? 2 times 2 times 2. Do you agree?
Yeah.
Okay. Let's take 14 and break that down into its primes. That's even easier. Right. 2 times 7. Okay? Now watch this very carefully. I'll use a different color. What I'm going to do is I'm looking at these numbers and I'm looking at these numbers. To find the least common multiple, I want to compare the numbers. I want to find out what numbers show up not just in both of them, but in either place. So what's the smallest number that shows up here? A 2. What's the smallest number shows up here? 2. How many times does it show up here? Just once. How many times does it show up here? 3 times. So what I'm going to do is I'm going to take the one that shows up the most number of times. So how many 2s am I going to choose? 3 of them. 3 of them, because it shows up here 3 times. Only shows up here once. It shows up here 3 times. You with me?
Yeah.
So what I'm going to do is I'm going to write 2, 2, 2. What other numbers show up? They don't have to be in both places. They just have to show up in those boxes. A 7 shows up. How many times does it show up here? Just once. Again, it doesn't have to show up in both places. What if, now this doesn't happen, but what if it showed up here one time? Well, it shows up here once, it shows up here once. We only pick one of them. Okay, because you will have situations like that. So now I multiply by a 7. Why did I multiply by a 7? Because a 7 shows up and it only shows up one time, so I just put it down once. What if this was a 7 times 7? Then I'd put 2 7s down, but it doesn't. Now, what do I do with all those numbers? Multiply them together. 2 times 2 times 2 is 8, times 7 is 56. That is my least common multiple. And what does that mean? That means that's my common denominator. You see that? So that's how you can find a common denominator if you can't just look at them and tell what it's supposed to be. Right? Now, we just do what we did before. Finding the common denominator is the hardest part about this. Once we found it, then we ask ourselves, what did we do to 8 in order to get to 56? Multiplied it by 7. So what do we do to the top? Multiply that by 7. What does that give us? A 21. What did we do to 14? Look, here's 14 right there. Do you see that? What did we do to 14 to get 56? Multiplied it by 4. So if I multiply that by 4, what do I multiply this by? And what do we get? It's 20. And then now we have a common denominator of 56. What's the top? 41. Okay? Always try to reduce it. Will this reduce? Now, 41's prime, so nothing will go into either one of those. So that would be my answer. I just made that question up off the top of my head. But that's basically how you do that. Okay? Now, what we're going to do is we're going to transfer that. Everybody's up here, right? We're going to transfer that to algebraic expressions, okay? It's going to have x's in it, it's going to have squareds in it, and all that good stuff, all right? So now let's take a look. We'll use this green color. I don't use that very much. Let's see. Let's do this first before we do an official example. What if we had A over B plus C over D, and I asked you to multiply those together? Yep, I think we did. Let's do it again. So what would our common denominator be in this situation? Just BD. So it would be BD right here, BD right here. Now, what did you multiply B? I don't think everybody's watching. What do we multiply this by to get BD? D multiplied by a D. And I think we did this yesterday or Friday, right? And we multiply that. So we get an AD. And then what do we multiply D by to get this? A B, right? So we multiply that by a B and we get BC. So what's our common denominator? BD. Add this, you get what? AD plus BC. All right? So that's how you do that. Now what we're going to do is we're going to do an official example here. This is 6A. Okay, ready to write this down? If you haven't written anything down up to this point, shame on you first. But at least write this down. First one's pretty easy. All right, so first thing I do, you could put it over one denominator. I'm just going to do it like this since we're just starting out. First of all, do we have common denominators here? No, we don't. So we need it. So just like right here, I had that B and that D. How did I get a common denominator? One way is just multiply them together, right? So what can we do here? Just multiply them together. Would you agree? Tell you what, let's not do two of them. Let's just put one denominator. Change my mind. So if I multiply those together, what do I get? X plus 4 times x minus 2. You don't need to distribute it. Don't worry about foiling it. Just write it down just like that. Okay, especially when we're trying to find the numerator. Everybody with me on that? It's kind of what we did earlier when you had that 3 and the 5, right? You just multiplied the 3 and the 5 together. That's basically all we did right there. Just multiply those two together. But now you got to ask yourself the question, what did you do to this in order to get that whole entire denominator? What did you multiply this by? X minus 2, right? So I multiplied the bottom by x minus 2, so what do I have to do to the top? Got to multiply the top by x minus 2. You with me? So let's write it down. So x minus 2 times x minus 3. So that's the first one. Now we do kind of the same thing to the second one. So put a plus right here. And now let's figure this out. What did we do to this in order to get to this? Multiplied by? You don't like that color? Is the green all right or the red's not good? Can't see the red? Okay. Okay. Just wait till this problem's over at least. Oh, is that what you said? Okay. All right. So we multiply the bottom by x plus 4. So we multiply what? The top by x plus 4. Okay, so I'm just going to write x times x plus 4. Well, you'd think we'd be done right now, right? Well, you'd think wrong. So what are you going to have to do to this? Can't just leave it like this because there's going to be some things. It's not factor. It's already factor. We've got to multiply them. That's right. We've got to multiply them through. So I'm going to put an equals. Now the thing is, we don't have to multiply the bottom. Don't worry about multiplying the bottom. Just keep the bottom the same because nothing's going to cancel out. But we are going to multiply this because you're going to have some like terms you can add together. Okay, so you always need to simplify. And you will have some like terms here. So let's do this. We've done this dozens of times now. This is just a little FOIL method, right? And we should be able to do the whole thing in our head. So that would be x times x is x squared. Then the outside and inside. That's the part you should be able to do in your head. What's the outside going to give you? Negative 3x. What's the inside going to give you? Minus 2x. What's negative 3x minus 2x? Minus 5x. You should be at a point where you could look at this and just write down negative 5x. If not, write it down, okay? Well, just write it down so you can see it, right? Negative 3 minus 2, or negative 2 minus 3. Everybody get that? All right, then the last, negative 2 times negative 3 is positive 6. Now, we're going to have to multiply these together. A little easier because you just have the x outside here, so it's a little distributive property. So what do you get? X squared plus 4x. Okay? Now, why did we do that? Because we got like terms. Look, I got an x squared here and an x squared here. I got to add those together. So that's simplifying, okay? If I can get like terms, I got to add them together. So if I didn't multiply that stuff right here, I would have never seen those like terms. So x squared plus x squared is what? 2x squared. All right, so I'm done with the x squareds. What other like terms do we have up here? Negative 5x plus 4x is negative x. I'm done with those. What else do I have on top? Plus 6. And all that is over x plus 4 and x minus 2. If you wanted to multiply the bottom out, you could. You don't have to. You can just keep it like that. And that's how they want you to write your answer, right there. That's the answer. You could go through the top thing. It looks like it might factor. You might want to go through and see if it can factor. It will not factor. So that's that. All right, we've got another one to do before we stop. There will be subtraction, yeah, but the denominator is going to look just a little bit different. This is example 4. I'm sorry. What am I doing? I'm on the wrong. Why did I put example 4? It's example 6. I don't know. On my notes I put 4. That's dumb. I know, but in my notes I had written 4. That's why I said I was dumb. So it's example 6b. So here we go. All right. Basically, it just says add the fractions, or just add, I think, or subtract, add or subtract, I think is what it says. So there it is. Now this looks a little different. Okay, that's why it's another example. Okay, they don't just give you the same exact problems for 2 different examples. They switch it up a little bit. So what's the first thing, looking at this, before you even find a common denominator, what do you think the first thing you're going to have to do here is? Yeah, I would factor this thing right there. Doesn't that stick out like a sore thumb? Yeah. And we've done this. We've factored it. What kind of factoring is it? It's a special kind of factoring. It's a difference of 2 squares. That's right. So I'll just do it underneath it here. Everybody watching? All right, let's do a difference of 2 squares. So I'm going to put my parentheses. So I got a plus and a minus. I got an x and an x. So what goes here? Do I put a 4 here and here? No, I take the square root of it, which is 2. Now that thing's factored. Minus 1 over x. This looks a little bit better. This looks kind of like what we've been doing today. Or at least we did in the last problem. So make sure you factor that x squared minus 4. That's important. Okay? So now what we're going to do is we're going to try to find a common denominator. Look at my denominator. I got an x plus 2, x minus 2 over here, and then I got an x right here. Is there anything in common with any of those right now? No. Well, no, but it's not really an x because it's not an x by itself, because this x is attached to this, minus 2. So really there's not an x in common. A lot of talking. Uh-oh. Why'd my screen go? Did your screen go dark? No, mine did. Am I not plugged in? There we go. Okay, so watch carefully. I've lost half of you already, so I'm just going to do it. So how can I find the common denominator here? What did I do with that 3 and the 5 on that other problem? I just multiplied them together. So what do you think I can do here? Just multiply everything together. Okay, I'm going to put that little x out front, just look a little nicer like that. And then, no, it doesn't matter. I mean, 3 times 5 is the same thing as 5 times 3, right? What? Yeah, I just said that. I said it just looks a little nicer if I stick the x out front. It doesn't matter, because look, 2 times 3 times 5, isn't that the same as 5 times 2 times 3? or the same as 5 times 3 times 2, right? Does it matter? Does it matter that the x goes first or last or in the middle? No. It just looks nicer having that x sitting by itself out front. That's why I did that. Okay? Now, here we go. Let's watch. What did we do to this? That whole denominator to get that. Multiplied it by x. That's right. So what do we do to the top? Multiply that by x. And what are we left with? It's not 3x cubed. Yes, it's just an x cubed. All right? Then a minus. This is very important. Now, what did we do to this in order to get this whole denominator? And x minus 2. That's right. We multiplied this by an x plus 2, right? And what else? An x minus 2. So what are we going to have to do to the top? The same exact thing. X plus 2, x minus 2. After you do these a while, you're not going to have to write. See all that stuff I wrote right there? You won't have to do that because you know you just write it up here. Okay? So I put minus. Let's go back to blue here. Stay color coordinated. Minus x plus 2. And then x minus 2. But we're not finished, are we? Well, we can't cancel yet because all this stuff is being subtracted. Everybody see that? She made a good point. Hope you're watching. All this stuff right here, you cannot cancel with this stuff down here because it's part of a subtraction problem. Remember we talked about that? All right, so, but what we can do is what? We might have some like terms to add up here. So we're going to have to add some like terms. So let's write x cubed, put a minus, and let's figure out what this is. Now, watch very carefully. This is super important, and I'm going to show you right here. Got a couple heads on the desk. They should be up. You should be watching. What I'm going to do is I'm going to put a parentheses because I'm going to multiply this through. I'm going to FOIL it. But that's all being subtracted. So I got to put all that FOIL stuff in a parentheses. It's super important that you do this. So let's FOIL it. That's going to be x squared and then minus 2x. Actually, it was just what it was before. But anyway, let's do it. X squared minus 2x plus 2x, which is 0, and then minus 4. So really, let me see. Yep. And this is all over. This is all over this. So let's rewrite this again. We're almost finished. Okay. Now remember, on these problems, I'm not going to make you multiply the bottom out. Just keep it like it was. Okay. But on this, what are you going to get? You're going to get x cubed. Distribute this negative through both of these things. X cubed what? Minus x squared. Is it? Plus 4. Very good. It's going to be plus 4 over all this stuff right here. X times x plus 2, x minus 2. In my notes, I said you could write it like this, or if you wanted to, forget that. Just write it like this. What they did, I don't know if they did it in the book. It's in my notes. What they did is they put x plus 2 times x minus 2 is x squared minus 4. So they made the bottom x times x squared minus 4. Okay, so that's how they made the bottom. All right. Either way, it doesn't matter. All right. But what I've circled right there is what we're going to do. So, yes, here's your homework.
Section R7B, page
And yeah, right, I gave it to you already. You should have it right in front of you.
69 to 70,
35 to 51. But in case you forget and you now watch, I'm calling this B. Everybody look up here. Everybody look up here. Ray, I said everybody look up here and you didn't budge. R7B, I'm calling it B because that's the second homework. Everybody see that? Don't get confused on how many times I've taught. This is my 4th time teaching R7, but it's only my second homework on R7. Does that make sense?
Yeah.
Why I did that? Oops, what happened right there? Okay, so it's I gave you a paper on this already, but I'm going to write it down anyway. 69 and 70, and it's 35 to 51. 35 to 51, and I only give you the odds. So there it is. That is your homework. So have that finished by tomorrow, okay? We'll take a few minutes to go over it in class, and I believe I'm giving you a worksheet tomorrow. Is that right? Yep, giving you a worksheet tomorrow that's very similar to these problems right here. It gives you some extra practice, okay?